Hey guys, welcome back to another podcast episode. This time I'm going to continue trying to evaluate how good my Semgrep rules are by running it against various different targets. This is another HTTP server off of GitHub. And first, let me just get set up here. Okay, this is the HTTP, all the contents of the server here. I don't think this is the command. Oh, wait, yeah. This is the URL for the project, so I'm just going to go ahead and restart from there. Let's clone the repo. Here. Compile it. Okay, cool, we compiled it. Let's run our Semgrep tool against it. Current rules, code. For findings, cool, let's take a look. What do we have? Okay, so apparently it uses sprintf with %s at these two locations in http.c at line 95 and walk.c at line 26. Let's see what those are about. Actually, we have some blank text. Let's make our lives easier. Close out of these tabs. What was it again? http.c line 95. Okay, so you see this is a sprintf with 2% s's used. It looks like the arguments are the directory and whatever this is, dpd name, maybe the resource name or something like that. I'm not sure. We see buff is the memory of memory regions being written into, and we also see that it's a char buff with the size being set equal to max line, which you see here is 1024. So the question is, do we control the arguments to either dir or dpd name, and can we get either of them to big enough to actually overflow it? Let's send directory view. So you see that this is called as part of send directory view. Okay, I'm gonna go ahead. Let's try just running this and see what happens. Accepting connections. I am just going to try. Actually, wait, I could just W again. I'm going to close out of here. Let's just use a terminal. CD temp. We get 127.0.0.1. I'm guessing port 80 might not be. Okay, it's not port 80. Let's see. Looks like it's 8,000. Reason why I say 8,000 is it's the only abnormal port really being listed here. So let's try it. Okay, so you see we got something. In addition to that, it wasn't shown at the same time, but we see here that it outputted, so I'm pretty sure it's port 8000. Cool. We also see here detaching after fork from child process. So chances are this is another model where there's a parent process that will just like fork a process which actually handles the child process. Chances are this code is ran in a child process. So we'll need to actually debug it from that context. Okay, cool. What other source code files do we have from here? Server.c, main, start HTTP response. Okay, so we see this is a while loop that is ran. Looks like this while loop will effectively handle individual, what is the right word? HTTP requests and HTTP requests. Process client, start HTTP response, too many clients. Add new. Oh, serve HTTP request. This is probably the function that actually handles HTTP request. Also, right now what I'm trying to find out is this send directory review. I'm just trying to quickly see if we can just look through the code base and evaluate how we can actually hit this function. So, server, what source codes file? http.c, server.c. So we see there's socket.c, server.c, and http.c. Is it in here? Start. Serve HTTP request. Okay, cool. So it is in here. Sprintf. Okay, so here we see there's another %s at line 156, which was not reported by this. So good news, I found that there is an instance where for whatever reason, oh, I think it's because it's s in sprintf and there's two arguments. Either way, oh, okay, might be, yeah, it might be because of that. Never mind. Cool. So it's in this function. Let's go ahead and see if we can just see where this function is called from. Send directory view. Okay. So it looks like here, if we give a request to a directory, it will return it. So I'm gonna try and make a request to a directory to see that. However, first there's a few things. Let's see. What is index.html? Actually, this is a bit interesting. Server.o, http.h. This, the fact that I'm seeing stuff like socket.c here, server.c, socket.io, what else? http.o. Those are all, let me show you. Those are all files in here. You see http.o, socket.c. Which the fact that I'm seeing a bunch of files in here makes me think that just doing a simple wget here will give me, well, yeah, hit the function send directory view. Let's go ahead and test this. We need to first set the follow fork mode to child. That way, when it forks, we will debug the child process, which that probably is what actually handles the code. And we'll break on send directory view. Continue. Let's see, does this work? I'm gonna clear out. And we see that we have indeed hit it. Okay, cool, this is good. We hit this. Where is the sprintf? Sprintf is right here. Happens in a loop. Okay, cool. I'm going to go ahead, let's disassemble this function so we can see exactly what the sprintf is called and break on that particular instruction. Right here. Send directory view not defined. Okay, for some reason it didn't didn't hit it. Okay, yeah, did not hit that breakpoint. Error in Okay, cool. What I'm going to go ahead and do, since it was debugging the child process and it's no longer doing it, we will need to reconnect to it. So to do that, HTTP server. I'm going to go ahead and kill this and rerun it. Address already in use. server. Give me a second. Okay, cool, guys. I finally stopped being smooth brain and just killed the process, so let's get back to this. What I'm gonna do, follow fork mode child. So we know that by setting a breakpoint or just simply sending a basic request, we will hit the send directory view. I'm just gonna break for sprintf and see if we land in the code path where we want to. And let's run this. Okay, cool. We're running this. Break. Okay, so it does not appear that we are hitting there. Let's take a look through this and see what's going on here. Wow. Okay, so let's take a look at this index.html and compare it. So we see here in the code it's printing trtd ahref, which we're seeing that like here trtd ahref equals. Okay, yeah, we see that href equals directory name, but why is it not hitting sprintf? Hang on a second. I'm gonna copy this. Okay, so you can definitely see that's repeated a lot. So I think it'd be fair to assume that this line of code is being, or it might not be, executed. Could be this right here. href equals. Where do we see parent? Where do we see this? Well, is this in a loop? This is not a loop. The fact that we're seeing that this string repeated multiple times means that it's probably being written within a loop itself. So this line of code is probably being executed multiple times, which means the fact that I don't see between this line of code and this sprintf right here, I'm not seeing any logical thing that would stop the execution. This sprintf is most likely being executed. It's just for whatever reason our breakpoint is not working. So follow fork mode child. This is what I'm gonna try doing. I can. So I confirmed that I'm able to break on this function being called in the child process. What I could just do, it might take me a minute, but just step through here and just verify that I am able to step through in the code that I am trying to hit is indeed being executed, excuse me. So let's go ahead and do that. First, we will need to kill this process so we could restart it. So let's kill that process. Okay, cool. Let's restart this. Since this is a actually, we need to set follow fork mode child. Break at set directory view. Oh, I forgot to run it. Okay, now we're running it. Okay, cool. We already see that we're here. I'm gonna go ahead and try stepping through it. I'm gonna pause the stream while this goes on. Okay, cool. So I think I found what the problem is with debugging this. So where is it? Start HTTP response. I was at this function. I stepped into it and then tried finishing it. and then we see that it detached. So let's go ahead and look at start HTTP response. Pretty sure what's going on here is it is forking of the process. P close, process open. Yeah, it's forking another process, which means since we've set the follow fork mode to be child, it's going to follow the child process. Another fork happens within the initial fork, so we stop debugging the process we actually want to. How we can solve this problem is here. We will simply just when we'll set follow fork mode to child, hit this breakpoint right here, and then set the follow fork mode back to the parent. That way we will not debug any more we won't follow the child process for any more forks, and that should lead us to actually hit that sprintf. So let's go ahead and reset the process. Right now I'm just killing the server process so I can restart it. I could probably just like reattach the GDB, but oh well. So follow fork mode child, break on send directory view, run it. Cool, we are here. Let's set follow fork mode parent. Cool. Break on sprintf. And we are here. Cool. So we see here that the format string is %s%s, which correlates with this right here. And on top of that, we see that RDI, RSI. The two arguments appear to be the directory name that it's the file stored in and the file name itself. And let's continue this a few more times. Yeah, file name, directory name, file name, directory name, and we see here server.c. Also, another thing that we're seeing is there's another sprintf. This is because of this one. Most likely right here, you see the format string is %d and oxb5a, probably like the file size, maybe. I'm not sure what that is. So, good news is we've confirmed that the argument to here is the file name and the directory name. Okay, and on top of that, the max directory name is max line, which is 1024. I'm gonna go ahead and pop. Okay, so yeah, now the question is can we use this to overflow buff? The quickest and easiest way I can think to do it is first I'm gonna go ahead and see what I'm gonna try and see is if I can create a directory with its own file of contents and do a request to there, and then see if that will actually have the same functionality. So to do that, I'm gonna info breakpoint delete 1, 2. Okay, continue with that. I'm gonna just make a directory. Let's call it this, and let's just make a simple file called test. And let's see if it can make a request to this. Let's go ahead. What is the process ID of this? It is here. I'm going to just reattach to it. Okay, never mind. Cool. Set follow fork mode child. Break on this right here. Send a directory view. And let's run it. Gonna try this time, port. I'm gonna look at the syntax. Hang on a second. I'm gonna just double check that the syntax for this right. Okay, let's see. Does this work? We sent a response for here, and we see that we hit it. So follow fork mode parent break at sprintf here test. Okay, cool. So what we are seeing is indeed test, which is the file name that is contained within this directory. Both the directory and test, they are both being displayed even though we made them. So ideally, just for a simple proof of concept that this is a bug, next up what I'm going to try doing is effectively making super large directory, basically a file path to the file, because effectively that's what this is. Going to try and make it large, much larger than 1028 or 1024, since that's what max line is, and see if that causes a buffer overflow. I'm going to pause the stream for a few minutes while I set this up. Okay, so I created a directory with as you can see, a super large file path name around like 1200 characters. We can see here that we're sending a request to it, and let's go ahead to follow fork mode child break at what send directory view, and let's go ahead and see if this works. Okay, so we broke here, so follow fork mode parent break at sprintf. Okay, so it appears that it is actually sending this giant, taking in this giant directory name. So let's go ahead and see if this overflows it. Saved RIP equal, wait a second, finish. I'm gonna, hang on a second, this is some thinking of an easier way to do this. Instead of breaking on sprintf, I am going to break at the sprintf instruction within this function that I care about, which I believe is this right here. Info breakpoints, delete 1, delete 2, fork mode parent, break at that instruction. Okay, so also what's going on here is because wget, I believe, since it didn't get the response back since it was debugging the server process, it just reset the request, which is what this is right here. RDI is this value right here, which if you look at the stack frame, saved RIPs here. Let's see how far away it is on the stack. If it doesn't exist already, I probably should just write a simple GDB add-on to Jeff to just calculate offset to saved RIP from whatever address you provided. RDI is this, which is the destination. 0x418, which is 1048, which 1048. If you look at RDX, that should be bigger. Repeats 200, 200, 200, 400, 800, 600, 800, 1,000. How big is this? Did I mess up? Only 1,004. Okay, I messed up. I did not make it as big as I should have. Let's go ahead and add on into each one of these subsets or directories. The length of the name is 200 characters. Right now I'm at 1,000 because I made a mistake. Let's try this. So we get 127,001 for 8,000. Gonna reset this. Or let's set the breakpoint for set follow fork move child. Oh, mistyped that command. It is thundering outside. Set the breakpoint for there, run it. Now let's try this. I'm gonna also need to make a file in it for it to actually hold stuff. Moment of truth. Does this work? Okay, so what we will be doing now, port 8,000. So follow fork. Okay, send. It does not. I'm gonna try. Let's try. What it could be is it could be a size check on the size of the directory, and then if it's too big, it just doesn't process the request. That could be what's going on here. In order to see that, an easy way we could is just see if going back another level will actually give us this breakpoint hit that we are looking for. Send directory view. Okay, so we have that. Set follow fork mode child. This is already in. We need to kill the previous server process. Sudo kill tag9 41249. Let's run this. Let's make sure we do this right. So wget. Let's see, does this work? Okay, so we see that that does work, which probably means it's a size check. Wait a second. You see the stack smashing detected, so we are actually smashing the stack. I think it is because of the stack buff. Give me a second. Okay, cool. So the good news is we are smashing the stack as stated here. The only question is, where is that happening? So, okay, cool. My prediction is that it's in the send directory view function. So, what we can do for that, let's first set up to do another, so we can debug it again. Okay, cool. Set follow fork mode child break at, what is it? Send directory view. And let's run it. I'm predicting it's a sprintf again. It's just due to smooth running mistakes. I was just, with my previous request, wasn't able to trigger that sprintf bug. So let's go ahead and send this. We are here now. Cool. Set follow fork mode parent. Let's disassemble send directory view. Believe this is a sprintf call where the buff is happening. Let's continue to this breakpoint. Okay, so we see what looks like a normal stack frame. Saved RIP equals this. Now let's step through and see if that gets overwritten. Does not appear to get overwritten. I'm gonna disassemble this function again one more time. Okay, I'm going to break here. That way I can see the state of the stack prior to it exiting. If it is this function that is having the stack smashing happen, then this call to stack check fail should terminate the program. Okay, let's continue. Sprintfs. Okay, let's see. Okay, cool. So we see that it is indeed that sprintf call. We see this is evident from the fact that, let's see, directly after we, hang on a second. Finish. Okay, cool. So here we see we're at the sprintf call. Saved RIP is normal. We step into the sprintf and then finish it. And then directly after it, we see that the saved return address has been overwritten. So we see that we have indeed used a buffer overflow with that on line 95. Actually, not line 95. Let's double check. Yep, and let's just go back and make sure that Semgrep flagged that, since that is the bug, or at least the bug that we flagged. There might be others. It's flagged. sprintfs 95. Okay, flagged it. Cool. So we've successfully were able to verify that at least one of the results of the Semgrep rules that were flagged was indeed a bug. One thing I'd just like to reiterate, the results from this Semgrep tool, they aren't designed to be like, hey, this thing is 100% definitely a bug. It's to narrow down and present a list of possible bugs. So if it gives me like 20 results and only one of them is bug, that is fine. But yeah, if it's the purpose of this tool is just to like narrow down the list of things that are actually relevant that I can look at for bugs. But yeah, cool. So we found this. I'm going to go ahead and submit an issue to the repo before uploading this. And yeah, thank you guys for watching. We were able to find a new bug in a random GitHub project. Thank you for watching.